Hi, my name is Carlos Villegas. I'm here to present to you my final project for digital forensics on Linux logs. I structured this presentation into 3 parts. Part 1 is your standard overview. Part 2 has screenshots and a demo. Part 3 has the technical nuts and bolts. You could argue that why isn't the demo at the end? Well, I thought that if I put the demo at the before the technical stuff, that you would find the technical stuff a little bit more interesting, because sometimes it can get a little dry. Hopefully that helps. So what motivated me to do my final project on Linux logs? 2 reasons. One, I really like Linux. I think Linux is a really good platform to work in, and most of the internet is run on Linux, by the way. Second, the contents of Linux logs are very important. They tell the story of what's happening on your servers, what's going through your wires, whether it's good or bad. So obviously for us in network security or digital forensics or system administrators, we're interested on protecting those assets that are connected in the data centers and holding safety critical servers and information. So we're interested about anomalies, and the Linux logs have all of that information in them. In the court of law for digital forensics, for example, it only counts what you can prove, and logs, server logs, router logs, everything, all that is a good source of evidence. So what is my final project? What is this Linux logs that I spent so much time on? Well, it really boils down to offering the user 2 really cool features, in my opinion. One, well, after parsing all of the logs into a relational database, it gives the user the ability to query on a time window. So for example, if you know that a file was deleted or was copied at 12 midnight, you can use my tool to query the database of all the logs that were parsed with a window, from a 10-minute window, let's say, for example, to see what commands, what movement happened before the file got deleted or after. Did the perpetrator copy it? Did he use Netcat to exfiltrate it out of the network, for example? All that gets recorded on there, and you could query that. That's one of the functionalities. The other one down here is where you can query, okay, let's say everything is loaded in the database, it's packed, everything, and you can say, okay, well, show me everything where root logged in. You can query that. Show me where a change owner command was used. Things like that. You can do that with this. I envision my tool assisting 2 types of people. One is the digital forensics professional. It's the person who snapshots a drive and then puts it under a microscope to extract all types of information that could be used to collect evidence to incriminate somebody that has broken the law. And the second group is the network security professionals or system administrators. These guys are more concerned with a live system, and this tool, although it currently does not support these latter folks, I envision adding functionality that will tell them, yes, this is normal, or no, this is outside the norm by 20%, by building historical trending and combining it with some near real-time monitoring, and we could even send out alerts if need be. So currently my tool, version 1.0, supports the Digital Forensics Professional. It does not support the network security professionals and system administrators yet. So we just finished part 1. Let's move on to part 2, screenshots and demo. For the first screenshot, I'd like to show you what the built-in user's guide looks like. You get it when you run my script without any arguments. I'd like to note that this is intended for two types of people previously mentioned: forensic investigators up at the top, and those guys normally work on disk images which they extract to a directory. So my script has an option that called root dir, which will redirect my script to read in the logs inside of that new root directory that contains the extracted disk image files. The second group is the network security people or system administrators. They are more interested in the host log files for the server. And so those two commands, either the root dir or the reset db, that the system administrators or network security people would use, are only executed once. Once they get executed, all the logs are parsed and stored into the database. So you don't have to do that again. Items A through D, those query, extract information from the query, those can be done in any order continuously. Okay, now for my second screenshot, I've tried to capture here what it looks like when log files are being parsed with the reset db option, or with the root dir option as well. You'll get the same output. They just work off of different roots. Okay, so let's look at the screen for a little bit. So the first log being parsed is the DMESG log family. As you can tell, there are many files in there. Some of them have are archive versions, and others are compressed versions. My script handles them all. You'll also note that if you tally up all the logs and you compare them to what was actually saved to the database, you'll notice a discrepancy in all three of these guys. The numbers in red represent duplicates. My script filters out duplicates in an effort to only save unique information to the database, to not waste time to the people doing the querying against the database. You don't want to show them duplicate information. They get irritated and then they stop using your tool. Here we see that the Xorg log family has a lot of duplicates, whereas the messages log family hardly has any, only 9, whereas the Xorg log family has over 2,000. this brings us to the screenshot that captures the main functionality of my final project, encapsulated in the query option. When executing my script with the query option, you feed it a string with a very specific format. The format is basically a date, a time, comma, and then the number of seconds minus and the number of seconds plus. Thus, all that information creates a window, a time window, a starting date and an ending date. And so we see that my script accepted the format because it validates it, and queries the database and displays all the records that fit within that window, inclusive, by the way. So it's greater than or equal to the beginning of the window and smaller or equal to the ending date time of the window. This example demonstrates the string match option. This is the option that should be used whenever you want to query the database for a specific string, like for example when root logs in, or when a dangerous command is executed, such as the change owner. This example took about of a split second. It was queried against a database that contains over 100,000 records. Indices are being used to reduce the query time. This screenshot demonstrates the logs option. It's a very simple option. It merely asks the script to print out all of the log names and log IDs contained within the database. This screenshot demonstrates the contents option. This option should be used whenever you want to display all of the contents associated with one and only one log ID. Now for the demo. I'm going to start off by showing you the built-in user's guide when you run Linux logs without any arguments. Let's do it. There it is, the Linux logs user's guide. Now I'm going to use my first argument fed into Linux logs. I'm going to use the logs argument, and here's what happens. It queries one of the tables in the database, and it brings back all of the logs, IDs, and log names. Let's jump to the top screen and let's verify this in the database. I am going to query how many records are in the logs table, which is what the previous example did. As you can see, it matches the number of records retrieved in the bottom screen. Now let's try something different. Let's use the argument contents with a log ID, one of the 14 that was previously shown, and we expect all of the contents to be displayed associated with that log. Let's do it. Let's use, what number? Let's use 8, just to say something. As you can see, it's quite a few. There we go. We finished. Okay, let's continue. Let's do something that is really nice. Once we have all the logs parsed and consolidated into the database, we can do things like this. Let's use the string match. Look how fast it brought back the results. So I asked the query, I asked the database, hey, show me all the records out there that have the change owner command in your description. And you saw how fast that was. Let me show you how many records it had to query to find this. Usually string comparisons are pretty time consuming. Hopefully you'll be impressed. I was when I saw how many records are in my specific database as a result of my live logs. So let's do this. Ready? That's 115,000 records. That did it very fast, in my opinion, for being such a small database engine, which is SQLite built into Python. Of course, if we had millions and millions of records, which is expected in a large production system or a collection of servers, you would want a heavier database like MySQL or Oracle or Sybase. So I saved the best for last. Let's query on time date window. Let's use the query argument like this. So we put in a date and time and the window size. It has to be of a specific format. It's in the user's guide. So it goes something like this. So let's say an event occurred at this date and time, 14 July 24th at 5:45 p.m. in the afternoon with 6 seconds. Now I'm going to feed it how many seconds before and after this date time to make my window. Let's go 2000 seconds. This is, of course, very specific to your data or your evidence. That's totally up to the investigator to decide what he or she wants to use. But nevertheless, here's the command to do that. So it found out that quite a few entries occurred throughout many logs in that time frame. And this is the purpose of my final project, to give this functionality. Regardless of where the log entry came from, you want to display it on a per time, date and time basis. This concludes the demo. I hope you enjoyed it. This concludes the demo. Let's continue on to part 3, the technical stuff, nuts and bolts. This is a short agenda of what this part contains. My final project, Linux Logs, was written in Python 2.7.5. I included a few statistics on the source code just to kind of give you a feel of what's under the hood. In terms of features currently implemented, there is a list of what the program currently supports, and as mentioned previously, those below are a list of features that are planned to be integrated in a future version. As you can see from this slide, it demonstrates that Linux Logs is properly documented. You can use your favorite documentation generation tool. This was used by ePyDoc version 301, but you can use any that you like. Now we get to which design pattern was used in Linux Logs. As you can see, the strategy design pattern was used, and the reason for that is because it easily allows you to switch out and tailor each log parser while maintaining a good cohesion and structure. This is just a little database schema diagram of what's inside the database. This is where all the data fits in. As you can see, we have two tables, and the parent one is the logs, and each log has a one-to-many relationships with the log events, and it's fully indexed in order to minimize the query time, and that's about it. Oh, yeah, I used this. I used the schema tool, even though it was not necessary, but I was exploring different tools. I always like to do that and learn what's out there. So this specific schema was generated with a program called DB Schema. It's I did it in Linux, obviously, and it supports Linux. I think it supports a few other OSs. They give you a free 15-day trial. Perfect for our purpose. But it was not necessary to use something like this. I just wanted to show some type of graphical representation of the tables and the relationship. This right here is a relational database. Very small one, nevertheless a relational database. This brings me to the end of my presentation. Thank you for your time. As you can see, my day job is programming and being an engineer. I am not a public speaker, nor I intend to be. So thank you for enduring. Bye-bye. Hope this was helpful to you. If you have any questions or comments or feedback, please, I welcome anything good or bad. My email is right there. Thank you.